Okay, this video will cover geometric series. It will give some background information, and then we will do a couple of examples. It'll probably be one of the longer videos on the playlist. So, a geometric series is the sum of the terms of a geometric sequence. Now, once again, as we mentioned earlier, that means it is a type of partial sum. So we're still going to use the partial sum symbol, where n is the number of terms being added. So we're adding up a specific number of terms, and that number will be the subscript. Now, once again, just like it was for arithmetic, there are two equations for geometric series as well, and again, it depends on what we know. If we know the first term and how many terms we are adding up, we are going to use the equation the partial sum equals the first term minus the first term times r to the n power over 1 minus r. And that is going to assume that r does not equal to 1, because if r equals 1, that would be division by 0. Alternatively, if we know the first term and the last term, we can use a slightly different version of the equation, a sub 1 minus a sub n times r over 1 minus r. Again, r cannot equal 1. And again, if r equals 1, that's a pretty not interesting sequence in series. Okay? So let's do some examples. Again, the big question you ask yourself is, do you know the last term? If you know the last term, you will use the bottom version. If you do not, you'll use the top version. So let's do some examples. We're asked to find S sub 8 for a geometric sequence where we know the first term and we know the common ratio. So we ask ourselves, do we know the last term? The answer is no. So we are going to use the version that is made up entirely of a1 and n. Okay, S sub n is a sub 1 minus a sub 1 times r to the n power over 1 minus r. Now you might be asking yourself, well, how the heck do I know what n is? Well, n is the subscript on the s. So n is 8. So we plug in what we know here. We're finding S sub 8, finding the 8th series, 8th partial sum. A sub 1 is 5, that's right here, that 5. So 5 minus 5 times, and then r, coincidentally, is also 5, to the n power, so to the 8th power, over 1 minus r, 5. So then we just have to use our calculator to simplify that down. So we'd start with the exponent on top, 5 to the 8th power, which is a pretty darn big number. So 5 to the 8th power is 390,625. Now while we're at it, we might as well do 1 minus 5 on the bottom because that's in parentheses anyway. Then we're going to carry out the multiplication. So 5 times that big number would give us 5 minus 1,953,125 divided by negative 4. Then we would do the subtraction. So 5 minus that would give us negative 1,953,120 divided by negative 4. So we carry out the division, and we get that S sub 8 is 488,280. Let's do another one. Same exact problem, different numbers. So again, we have our n value is 10. We know a sub 1, and we know r. So we do not know a sub n, which means we're going to use the top version of the series equation, a sub 1 minus a sub 1 times r to the n over 1 minus r. So let's see here. We're looking at s sub 10 because n equals 10 equals a sub 1, which is 2, minus 2 times r, which is 3, to the 10th power, because n is 10, over 1 minus r, which is 3. And again, we're just going to simplify that down. So we have 2 minus 2 times 3 to the 10th power. Again, big number, 59,049 over negative 2. We're going to multiply that by 2, which gives us that s sub 10 is 2 minus 118,098 divided by negative 2. Then we're going to do the subtraction. So 2 minus that big number is negative 118,096. And then we're going to divide by negative 2 to give us that s sub 10 is 59,048. 59,048. We're going to do one more example so we can see one using the other equation. So here is one where we're asked to find s sub n. We are given the first term, the last term, and the r value. So we are going to use the second version of the series equation because we know a sub n. So that would be a sub 1 minus a sub n times r over 1 minus r. Now we do not know what n is, so we're just going to continue to refer to this as s sub n. We don't even care what n it doesn't matter. So we have three numbers again. We have a1 is 2,000, we have an is 125, and we have r is 1/2. Now I'm going to go ahead and convert 1/2 into 0.5 because it's a really nice decimal, and that will actually make our lives a little bit easier if it's a decimal in this case. So a sub 1 is 2,000 minus a sub n, which is 125, times r, which is 0.5, over 1 minus 0.5. Again, our goal here is to simplify that down to a single number. So we have 2,000 minus 125 times 1/2, which is 62.5. over 1 minus 1/2, which would be 1/2. So s sub n is 2,000 minus 62.5, which is 1,937.5 divided by 0.5. So carry that out, divide by 0.5, and we get that the partial sum is 3,875. That does it for basic geometric series.